Okay, let's look at Newton's second law of motion. So it states that acceleration is directly proportional to the net force and inversely proportional to the mass. Now let's break down some of the terms used. Okay, now the net force or the resultant force is just the vector sum of all the pushes and pulls which are applied on the body. Now the mass is actually the measure of the amount of matter that the body has, while the acceleration is the rate in change of velocity, which means that it's actually measuring how fast a body is changing its speed in a given unit of time. Now, let's look at Newton's second law of motion as an equation or as its formula. So this is going to be A equals F over m, showing that acceleration is proportional to force and inversely proportional to mass. Now, this shows that if your small car breaks down, if more people push it, then the acceleration will be greater because there is more force applied. Now, however, if you are on one of those big buses and suppose it breaks down, you would barely move it even if everyone got out of the bus and started pushing it. Why? Because it has more mass. Now, let's see how Newton's second law of motion can be used quantitatively. Now, here's a problem. If a car of mass 2 tons moves on a level road while applying a total driving force of 3,000 newtons and a frictional force is applied on the car of 1,000 newtons, calculate its acceleration. So first of all, let's write down the equation A equals F over m. So now let us find the net force in the first place. Now since this is a vector sum, the net force is going to be equal to the driving force minus the frictional force. This is going to be 3,000 minus 1,000, giving us 2,000 newtons. Now secondly, let's find the mass in kilograms. Now the mass in kilograms is going to be as follows. If 1 ton equals 1,000 kilograms, then 2 tons is going to be equal to 2,000 kilograms. Great, we have everything that we need. So now let's just get the formula again. Acceleration is equal to force over the mass, and we're going to say 2,000 newtons divided by 2,000 kilograms, and this is going to give us 1 meter per squared second. In